look at the first example. So the Kentucky Derby is a distance of 10 furlongs. How far is the Kentucky Derby in yards? So if we look here at this example, at this chart, we do see 1 furlong right here. I'll highlight it, 1 furlong. And it says it's 40 rods and 1/8 mile. Okay. I don't need rods or miles. The first one is saying convert from furlongs to yards. So one thing I do see is that I can go from 1 furlong to 1/8 of a mile. And then there is a conversion between 1 mile and yards, right? So that's kind of the track I'm going to go. I'm going to go from furlong to mile and then from mile to yards. And when it says 1/8 of a mile, 1/8 of a mile is the same thing as 0.125 miles, right? 1 divided by 8. So that's the first conversion I'm going to use. 10 furlongs, I start with what's given, is the same thing as 1 furlong is 0.125 miles. That's my first conversion. This way the furlongs will cancel and I have miles. And then we saw there was a conversion from miles to yards. It said 1 mile is 1,760 yards. And so miles can cancel diagonally. And my final answer is in yards. So then we're just multiplying these values, 10 times 0.125 times 1,760. You just multiply across. And if you do that, you should get 2,200 yards, which is what I wanted my final answer to be in yards. And so I was mentioning that in our module 2 unit or tab in Canvas, there's this PDF that says module 2 conversion sheet. If you guys just click that link, you'll see all these conversions here. This will be useful for you guys to print out and use on your homework, quizzes, and even the test. I will allow this. I don't want you guys memorizing these conversions. So look at part B. B is saying I want this 10 furlongs in feet. And so go back to your conversion sheet for a minute. Again, here's the furlong. I highlighted it there. There is no direct conversion from furlong to feet. But you do see here, there is a conversion from yards to feet. 1 yard is 3 feet. And actually in part A, we just converted 10 furlongs to yards. So now what I'm going to do is I'm going to say, I know 10 furlongs is 2,200 yards, right? And then the conversion I just highlighted below said, or on the other tab, I should say, is 1 yard is 3 feet. So I'm going to put 1 yard here and 3 feet here. That way yards can cancel diagonally. And I'll put a parenthesis there. And then we can just multiply it across. 2,200 times 3 is 6,600 feet. And that is how we can go from here. We ultimately went from furlong to yards and then yards to feet. Okay, I'll do one more. Let's look at C. It says, what is your average speed in miles per hour and in feet per second if you run a mile in 4 minutes? So this is what I have. I ran a mile, which means 1 mile. So I'm going to write it like this, 1 mile in 4 minutes. Now, they're asking me to do 2 things. The first one says, what is the average speed in miles per hour? So look at my units that I have currently. I have miles. So they're asking still in miles, right? But minutes needs to change to hours. So that's the only thing I'm focusing on changing. The miles is going to stay there. The relationship between minutes and hours is 1 hour is 60 minutes. Now, because I want the minutes to cancel, I need to place the minutes diagonally from this 4 minutes, which means I'm putting 60 minutes here so that you see diagonally they can cancel, and 1 hour here. That is the relationship between the two. 1 hour is 60 minutes. And then I multiply across, which means I do 1 times 60 is 60. 4 times 1 is 4. And 60 divided by 4 is 15. And look at the units, mile per hour. Which is what they wanted. They also, and I'll do this in a different color, they also wanted 1 mile in 4 minutes in feet per second. So let's start with, again, 1 mile in 4 minutes. Now I need to convert two things. I need the miles to convert to feet, and I need the minutes to convert to seconds. So let's look back at that table and see what is the relationship between miles and feet. Is there a conversion I can use? And so if we look here, take a look right here. It says 1 mile is 5,280 feet. That's the conversion. That's the relationship between the two. 1 mile is 5,280 feet. And take a look here. I actually have 1 mile. So I can just say directly 1 mile is 5,280 feet. And I still have the 4 minutes. So I've done the first part. I've changed to feet. But now I need to change the minutes to seconds. And so the relationship between minutes and seconds is, we know 1 minute is 60 seconds. And again, here, I'm trying to figure out, I need minutes to cancel. So I need to put this 1 minute diagonally like this so that the minutes can cancel. And I have 60 seconds there. And so now we multiply across. You would do 5,280 times 1. And then, so that's 5,280. And you have 60 times 4, which is 240. And if you divide the two, you would get 22. And again, take a look at the units here, feet per second, which is what I wanted. Feet per second. Let's look at example 2. This is talking about price comparison. So it says, decide which of the two given prices is the better deal. So here's the first option. You can buy a box of 150 Sharpie pens for $165, or a dozen, which means 12 Sharpie pens, for $13.50. We want to know which choice, which is the better option. So to do this, we actually should find the price for 1 pen in each of these options presented. So even though they're giving me the first one in bulk, you pay $165 for 150 pens, I can figure out how much 1 pen is by doing $165 over 150, I'll just write pens. When I divide those two, 165 divided by 150, I get $1.10. That's the dollar amount per pen. You see my units, dollar and pen. So for 1 pen, it costs $1.10. I'm going to do the same thing with the other option. It said for a dozen pens, which means for 12 pens, you would spend $13 right? For 12 pens. So if we divide these two, you always put the money on top, right? If you divide 13.50 by 12, you would get $1.13 per pen. That means 1 pen costs $1.13. So which one is better? It would be the cheaper option, which would be this one, buying in bulk in this case. Let's look at B, similar problem. Here's your two options. You can fill a 15-gallon tank of gas for $32.25 or buy gas for $2.55 per gallon. So again, when you're presented with options like this and we're being asked what's the better choice, you look for how much does it cost in this case for 1 gallon of gas? How much would it cost you? And compare that in both scenarios for 1 gallon. So to do that, I'm going to set it up the same way. I'm putting $35.25 for 15 gallons. And if I divide those two, I would get $2.15 per gallon. So that means in this deal, to fill up 1 gallon, it would cost $2.15. And they've already presented the other option in that way, $2.55 per gallon. So which one is the better deal? The cheaper one, $2.15 per gallon. Okay. The next thing I want to look at, and we'll do more of an example a little bit later, but I'll introduce it now, is the metric system. So what we've been doing actually in the first example here, where we're using miles and yards and feet, this is part of our US system of measurement. We call it the US customary system. That's where we use feet, yards, inches, and so forth. The rest of the world uses a different kind of system for measuring. They call it the metric system. And so for the metric system, you have something called basic units. And we have basic units for certain things, such as length, mass, which is weight, time, and volume. These are the things that we look for, that we try to look for in the metric system, or we can use. Now, when it comes to length, the base that we use in the metric system is meter. They don't use inches or yards or feet. They use meter to measure distance or length. And the abbreviation for meter is M. For time, they use seconds. And you see there, the abbreviation is S. For mass, so when we're talking about weight, we use pounds in the US, but everywhere else, they use kilogram. kg is the abbreviation. And finally, for volume, liter is what is used, which is abbreviated with a capital L. Meters, seconds, kilograms, and liters are what we call our base. So as we look at this table below, you see where I put unit. I want you to write there base. And that's where I put meters, grams, liters. Those are our base units, depending on what we're measuring. If we're talking about distance, then it's meters. If we're talking about weight, it's grams. If we're talking about volume, it's liters. But then you also see on this table these prefixes: kilo, hecto, deca, deci, centi, milli. I put what it means. That's what these numbers on the top mean. So look at the base word, meters. If I add kilo in front of it, that says kilometers. I'm sure you've heard of that. Kilometers is, and that's where I wrote this number, 1,000 times bigger than the meter. Hectometer would be 100 times as big as a meter. Decameter is 10 times as big. Meter is the base, and then you have decimeter, centimeter, millimeter. And I'm sure you've heard of centimeter and probably millimeter before. And that's where it's based off of this metric system. You're just changing the prefix here. And so past the base, as you're going to the other side here, these are small units. So this is like 1/10 of a meter, 1/100th, 1/1000th, very small. So we go from large, kilo, all the way to milli, the smallest unit. And so I can do a quick example here. If I asked you to go from, let's see, 50 centimeters to meters. What you do is you start with what you're given, 50, and you look for its decimal place, which is right here. And so take a look at this table. I'm starting at centimeter here, and I want to end up here at meters. So I go 1, 2 to the left. And so that's the direction I'm going to move this decimal place, 1, 2. So 50 centimeters is actually 0.50 meters. That's kind of how this metric system works. Now, I have a saying that'll help you here to do this and to remember the metric system, which is, instead of remembering kilo, hecto, deca, I say king, that stands for K, kilo, Henry died by, that B represents the base, drinking chocolate milk. And so hopefully you can see K here for king, kilo, H, hecto, D, deca, B, by means base, drinking, deci, chocolate, centi, milk, milli. So it kind of helps you remember. So when I do these kinds of problems, I write King Henry died by drinking chocolate milk. I kind of do like that. And then I say centimeter. Okay, centimeter is here. Where do I want to go to from centimeter? I want to go to meters. Meters is considered my base. So, oh, sorry, I missed a spot. Drinking chocolate milk, sorry. So I'm here and I want to go to meters, which is a base. So I would go 1, 2 to the left. Take my decimal point and move it 2 to the left. So it's very easy if you're converting units that are within the metric system. It's really easy. All you're doing is just you're moving your decimal point. We don't have to look at this table and do this math. We're going to skip example 4. You don't need to worry about that. And let's do some in example 5. So if we look at this, I meant to write 13 here. So let's say I wanted to convert from 13 liters to quarts. Now, liters is part of your metric system, but quarts is not. Quarts is a US measurement that we use. So I do have to look at my table and figure out, well, is there a conversion between liters and quarts? So I always start with what I'm given, 13 liters. And I'm going to figure out if there's a conversion between liters and quarts. So if we look here, go down to here where it says metric to US conversions. And let's see, it should say right here, there is a conversion between liter and quart right here. 1 quart is 0.9464 liters. So I'm going to use that. And so I want liters to cancel. So I'm going to put the liters diagonal here so that, see, those L's will cancel, and 1 quart on the top. And so now we just multiply. You would do 13 divided by 0.9464. And when you do that, you should get 13.7. And again, your final answer is in quarts. Let's look at one more here. It says 4 square kilometers to square miles. Okay, so we're starting with, and I'll write that here, 4 square kilometers means your kilometers is squared, right? That's what that means. Now, I'll find a conversion between square kilometers to square miles. Let's look on the other page. I don't see where it says square. So that's going to be something that we need to figure out. What I do see here is this: 1 kilometer is 0.6214 miles. That's the only thing I do see. So we're going to have to square both of those because we need square kilometers and square miles. So if we do that here, let me go to the other page. So this said 1 kilometer is 0.6214 mile. So let's write that here. 1 kilometer is 0.6214 miles. We need everything to be square miles. So look what that means. That means I want to square this, meaning raise it to the second power. And when you square the number and the units. 1 squared is 1 kilometer squared. And then on your calculator, you would do 0.6214 squared, meaning multiply 0.6214 times 0.6214. And so here you should get like 0.3861 miles squared. Right? So I want my kilometer squared to cancel. So I'm putting it diagonally like this so it can cancel. And I want my square miles there on top. So if you multiply 4 times 0.3861, you should get, rounding to the nearest tenth, 1.5 square miles. These, you would just look here at this portion. Another thing we're going to look at is temperature. So these temperature conversions, you see the first example, we're going from Celsius and Fahrenheit conversions, going back and forth between Celsius and Fahrenheit. That is right here. We'll see temperature conversions here. So we're focusing right now on Fahrenheit formula and Celsius formula. So actually, I'll write those two on the side here so that we have them. So Fahrenheit is 1.8 Celsius plus 32. And then Celsius is Fahrenheit minus 32 divided by 1.8. Those are the two formulas we're going to use. So let's look at the first example. We have -8 degrees Celsius. And so what they're asking is convert it to the other temperature, which means we're going to convert this to the different scale, which is Fahrenheit. Now, you can use either of these two formulas, but there's always a better formula to pick, in my opinion. And the one you should pick is what you want your final answer to be. So in the case of part A, if they're giving me the degrees in Celsius and I want my final answer in Fahrenheit, then we should pick the equation that's solved for Fahrenheit. that says F equals, because it will be much easier to plug in the Celsius and solve for F. It is already solved for F. So I'm going to use this formula for Fahrenheit. And what I'm going to do is they say -8 degrees. That is my Celsius. So I'm plugging in -8 for C. And you can plug this into the calculator directly like this. And if you do, you should get 17.6 degrees. That would be your answer for -8 degrees Celsius is 17.6 degrees Fahrenheit. And so we can do the same thing for B, if you like. So for B, it's giving me the degrees in Fahrenheit. And we're being asked, what is this in Celsius? So again, here, the equation I would pick is the one solved for Celsius, what I want my final answer to be. So here, I'm going to plug in 15 for F. And so when you do that, you do 15 minus 32, that's -17 divided by 1.8. And if you do that on the calculator, you should get pretty much like -9.4. And this is degrees Celsius. Okay. Now, I'll do one of these two. This is, again, just a different system. We want to be able to go back and forth between Celsius and Kelvin. So again, we're looking at temperatures, but now we want to go between Celsius and Kelvin. So let's look at A. Here are the formulas on the other page for Celsius and Kelvin. And so I'll write those two here. You can either use K, which stands for Kelvin, is equal to C plus 273.15, or Celsius equals Kelvin minus 273.15. These are our two formulas. And again, there's always a better one to pick. So look at A. If I have -40 degrees Celsius and I want to convert that to Kelvin, pick the equation that's solved for Kelvin. So I would use this equation and plug in -40 for C, because that stands for Celsius. So this would be -40 plus 273.15. And if you do that, you should get 233.15, and this is Kelvin. So we've converted between Celsius and Kelvin. Okay. Then I'm going to move to density. So when we talk about density, we're talking about how compact something is. And the units for density is right here. It is the mass. Again, mass means like the weight, right? Mass over unit volume. Now, there's different kinds of densities, and that's what I want to briefly talk about. There's material density. So you're looking at the compactness of an object, like a table or a chair. And so if it was a material that we're looking at the density of, these are the units you would want to use. Grams, and again, that makes sense because grams is a way to measure mass, right? Weight. Grams per cubic centimeter. And hopefully you recognize anything that has to do with volume, we said is always cubed, right? Raised to the third power. And so grams per cubic centimeter. If we're looking at the density of people, of a population, how populated is this area per square mile, something like that. This is population density, and the units for that is people per square mile. And finally, you could look at information density. And so with that, we're talking about maybe like a disk drive or a hard drive, something technology-wise, if you're looking at how compact it is. the units would be gigabytes, that's what GB is, gigabytes per square inch. So again, all we need to focus on is density is about how compact something is. And we have different types of densities. We could have an object or material density, population density, where we're looking at how crowded or populated a certain area is, or information density. And so highlighted to the right are the units. This is how they would be structured. So we'll do one or two of these. Let's look at example 8 here. Let's look at A. So it says a block of oak has a volume of 200 cubic centimeters and weighs 0.12 kilograms. What is its density? Will it float in the water? The first thing I need to do is, I do see that it's directly asking me for density, right? Now, I just mentioned there are 3 different kinds of density. So what density are we interested in here? Talking about a block of oak, so that's an object, right? So once I've determined what kind of density it is, then I go straight to, okay, what are the units? The units for material density need to be in grams per cubic centimeter. And then I look at, well, what did they give me? They gave me 200 cubic centimeters, so that's good, cubic centimeters. And the weight is 0.12 kilograms. Now that's an issue. I have kilograms given, but I need it to be in grams. And this is where I'm going to scroll up for a second so you guys can see. The metric system comes in. Remember, kilo, I'm going to circle that right here, is a prefix. And gram, let's highlight that, is a base. So I'm going from kilogram to gram. So this is perfect. I'm going to show you guys again how we can do that very quickly. On the top here, I'm going to write that phrase. Let's see, where should I do it? Let's write it right here. King Henry died by drinking chocolate milk. So we are in kilograms. That's over here, big K, right? And the material density says we need to go to grams. Grams is the base. So look, I'm going to go 1, 2, 3 to the right. So if I had, let's do it right here, 0.12 kilograms, go 1, 2, 3. That means when I do that, I'm adding a 0 there. Let me move this kilogram so you can see that. You see, there's no number where I moved it here, so you add a 0, and my decimal point goes there. So this is 120 grams. I'm almost there. I want the density, and it's saying we've determined this is material density. It needs to be in grams per cubic centimeter. So I just changed 0.12 kilograms to 120 grams. So I'm going to write that out, 120 grams per, okay, and they gave me 200 cubic centimeters. That means centimeters cubed. So now I'm just going to divide 120 by 200, and I get 0.6 grams per cubic centimeter. And that is my answer as far as the density goes. That is it. Now, the question of will it float in the water? This is something that I'm sure you don't know it, but I'll give this to you. Anything under 1 gram per cubic centimeter will float because it's so light. So if we know that, then definitely this block of oak, it's under 1 gram per cubic centimeter. It's 0.6. So it will float. And let's look at B. B is a 2-part question, but I'll do 1 part, and hopefully that'll make some sense. It says a standard DVD has a surface area of 134 square centimeters. Depending on formatting, it holds either 4.7 single-sided or 9.4 gigabytes double-sided. Find the density in both cases. So again, it's very clear they're asking me for density. These kinds of problems, it'll state that. It'll just say, what is the density? So your next task is to determine, well, there's different types of densities. Which one are we talking about? An object, it's a material. But anything technology related, let's shift our perspective to that's probably information density, if that makes sense. And then I see gigabytes here. So that's also an indicator to me that it's information density. Because if you see above, the units is gigabytes per square inch. So let's do just one of these. They're asking for the density when it's single-sided and double-sided. But if you see me do single-sided, it should make sense. So we see for single-sided, it's 4.7 gigabytes, right? That's the units. So I have the gigabytes. If you look up here, I need gigabytes per square inch. What I don't have is the square inch. They give me 134 square centimeters. So is there a conversion between inches and centimeters? Well, if I go back up here, I do see the first row, it says 1 inch is 2.54 centimeters. But the problem is I need square inch and square centimeter. So what I'll do is I'll just write what I got, which is 1 inch is 2.54 centimeters. And then remember, if we want the square, we're just going to square this and square this. And when we square the number and the unit. So 1 squared is 1 inches squared. 2.54 squared means 2.54 times 2.54. That's 6.54 centimeters squared. So this is the conversion I will use to change 134 square centimeters to square inches. So let's start with 134 centimeters squared. I want to change that to inches squared. So I'm going to put the 6.54 centimeters squared on the bottom so you see they can cancel diagonally. And I'll put the 1 inches squared on top. And then when we multiply across, we should get 20.78 square inches. And remember, look above, for information density, we're talking about single-sided. We have 4.7 gigabytes, and we just found 20.78 square inches. And if we divide the two, you should get 0.23 gigabytes per square inch. And that is your answer. If it was double-sided, I'll just set it up for you. You would just do 9.4 gigabytes divided by the 20.78 square inches, and you would divide the two. You should get 0.45 gigabytes per square inch. And the last thing I want to talk about today, this is pretty applicable if you're going into anything health related. If there's any nursing students, you might be familiar with this. And so we're talking about units of concentration. Basically, substances, one substance mixing with another. That's what we're dealing with. And so this happens in different scenarios. Air pollutants is one of them, where you have molecules mixing with air particles. That could be a case where that air concentration. You have it when you take medication all the time, or even IV drip. That's another one. You take any kind of medication, those the concentrations in that or the ingredients, I should say, in the medication mix with your body, your weight, and so we have concentration of medicine. And then finally, we have blood alcohol content. We abbreviate by saying BAC. And that is the alcohol mixing with your blood. Okay. And so also take a look at the units for blood alcohol concentration. It is grams of alcohol per 100 milliliters of blood. Okay, that's the units for that. So let's look at the first example here, example 9, medication dosages. Suppose a penicillin dose of 9,000 units per kilogram of body weight taken every 6 hours is prescribed for treatment of a bacterial infection. For penicillin, 400,000 units is equal to 250 milligrams. Okay, so it says express the dose in milligrams per kilogram of body weight. So what we have is this penicillin, and it says the dose is 9,000 units per kilogram. That's what we're given. And we're supposed to take that every 6 hours. But the dosage is 9,000 units per kilogram. So I'm going to write that here. 9,000 units per kilogram, which means per 1 kilogram. Now, the question is express the dose in milligrams per kilogram. Well, they gave us 9,000 units per kilogram. How do I convert units to milligrams? Well, it does tell you here 400,000 units is equal to 250 milligrams. That's the conversion I will use. It was given in the problem. So again, I want the units to cancel. So the 400,000 units is what I'm going to put in the denominator, and the 250 milligrams on top. So the units will cancel. And so here we would just multiply across. You would do 9,000 times 250. And I can write that for you. We do 9,000 times 250, that's 2,250,000 divided by 1 times 400,000 is 400,000. And if you divide that on the calculator, you should get 5.625 milligrams. Look at the units here. Let me highlight it for you. Milligrams per kilogram. And that's what we wanted. Look at part B. It says, how many milligrams of penicillin would a 20 kilogram child take in one day? So I have a 20 kilogram child. You always start with what's given. This is their weight, 20 kilogram. And we're asked, how many milligrams should that child take? Well, we just found above, you see right here what I'm highlighting, that's the dosage in terms of milligram. So I'm going to go ahead and write that next. We want to know how many milligrams. We said 1 kilogram is 5.625 milligrams. So these kilograms will cancel. And my final answer is in milligrams, which is what I wanted. It said, how many milligrams should this child take? So if you multiply 20 times 5.625, you should get 112.5 milligrams. But this is the tricky part of this question. It says, how many milligrams should the child take in one day? And notice something above. I'm going to highlight it. It says this medication, that dosage should be taken every 6 hours. So what I just found here, this 112.5, that's per dose. I want to make that clear. And so if there's 24 hours in the day, and I'm supposed to take this medication every 6 hours, 24 divided by 6 means I need to take this 4 times a day. So how many milligrams should I take a day? Multiply that dosage by 4 hours. Right? Because I have to take, I'm sorry, not 4 hours. I apologize. 4 times. I'll just say multiply by 4. And so if you do that, you should get the exact amount that you need, which is 1 tablet every 4 hours. So that's 450 milligrams. That's how much you should take in the day. The last example I want to do involves the blood alcohol content. It says 8 ounces of a hard liquor such as whiskey typically contains about 70 grams of alcohol. A 180-pound man with approximately 6 liters, which is 6,000 milliliters of blood, quickly drinks 8 ounces of hard liquor. If all the alcohol were immediately absorbed into his bloodstream, what would his blood alcohol content be? So let's answer that question first. If we're talking about blood alcohol content, let's look at what units it should be in. It says it here, it should be in grams of alcohol per 100 milliliters of blood. So grams over 100 milliliters. Well, we're told he took 8 ounces of whiskey, and that was 60 grams of alcohol. So I'm setting up 60 grams, and he's a 180-pound man with, we don't want liters, right? It says grams per milliliter. So he has 6,000 milliliters of blood. Okay, so I'm going to divide those two. And if I do that, I get 0.012 grams per milliliter. The issue is I need, and look up here, grams per, it says 100 milliliters. You see here, this is like 1 milliliter. So what I do is I multiply top and bottom by 100. And if you do that, you would get 1.2 grams over 100 milliliters. You're doing 0.012 times 100, which is the same thing as moving the decimal point 2 places to the right. And then 1 times 100 is 100. That is his blood alcohol content. Now let's look at the next part, part B. It says, assume that all the alcohol is absorbed immediately, but the man's blood then eliminates the alcohol through metabolism at a rate of 15 grams per hour. What is his blood alcohol content 4 hours after drinking the liquor? And then is it safe for him to drive at that time? Okay, so here we're given the same thing. He took 70 grams of alcohol. He has 6,000 milliliters of blood. We found his blood alcohol content, right? 1.2 over 100. Except now he eliminates the alcohol at a rate of 15 grams per hour. So we want to know his blood alcohol content 4 hours after. So all 70 grams is not there in 4 hours. If he's eliminating 15 grams of alcohol per hour, and we're looking at after 4 hours, let's do 15 grams times 4 hours. That means 60 grams, I'm going to write here, is eliminated in 4 hours. 60 grams of alcohol is eliminated in 4 hours. Well, if there was 70 grams of alcohol in that whiskey, and in 4 hours, 60 grams of that alcohol is gone, that means he only has, his blood alcohol content is 10 grams. And we know he has 6,000 milliliters of blood. So remember, to do the blood alcohol content, we're going to divide 10 by 6,000, and you would get 0.0017 grams per milliliter. But we need it to say per 100 milliliters. So we multiply top and bottom by 100. And if we do that, that's 0.17 grams over 100 milliliters. That is his blood alcohol content after 4 hours. Now, the last part of this is it safe for him to drive? So the legal limit, or I'm sorry, let's say this, for a DUI, it's 0.08 grams per 100 milliliters or above, right? That's illegal. You would be charged with a DUI. So here, 0.17 is greater than 0.08, right? So this is still not safe to drive.